To run complex applications like generative AI, we generally rely on massive remote server farms pushing data over the internet. But right now, the tech industry is racing to move that computation off the cloud and directly onto the devices in our hands. The challenge is that running large language models locally requires an enormous surge in data processing. The model has to instantly access billions of parameters to generate a single response. And unlike huge server racks, mobile devices lack the physical space for desktop-level logic boards and cooling systems. Engineers call this the mobile AI trilemma. On-device AI requires extreme speeds, minimal power consumption, and microscopic dimensions. But optimizing one metric ruins the other two. Pushing data faster typically drains the battery or requires a massive chip. Until a single piece of hardware can satisfy all three of these conflicting demands simultaneously, running high-end AI seamlessly on a phone remains impossible. Samsung has recently developed a specific storage solution engineered to break these constraints, called Universal Flash Storage 5.0. Looking first at the speed constraint, this chip integrates the newest embedded memory interface standard from JEDEC, the organization that develops open standards for microelectronics, allowing for incredibly high data bandwidth. This chart shows the exact performance leap. The UFS 5.0 solution hits a sequential read speed of up to 10.8 gigabytes per second and a write speed of up to 9.5 gigabytes per second. That is more than double the previous UFS 4.1 standard. For a user querying a large language model on their phone, this huge jump in bandwidth cuts down latency. The device can process large datasets much faster, meaning the AI responds without lag. But doubling data speeds introduces the second constraint. Pushing that much information usually demands a massive spike in electricity, which threatens the lifespan of mobile batteries. To solve this, engineers implemented clock gating, a technique that turns off parts of the circuit when they aren't needed, alongside multi-voltage technologies to tightly manage how electricity flows through the chip. This graph shows the result of those innovations. Even with the data throughput line rising steeply, the actual power required to move that data drops, resulting in a 40% improvement in power efficiency compared to UFS 4.1. By moving twice as much data while drawing significantly less power, the new storage solution successfully resolves the first major hardware paradox. Still, a highly efficient, high-speed chip is useless if it cannot actually fit inside a modern mobile chassis. Samsung compressed the UFS 5.0 package down to a footprint measuring just 7.5 millimeters wide, 13 millimeters long, and 0.9 millimeters thick. That ultra-compact package makes it exactly 16.7% smaller than the previous generation. Reclaiming fractions of a millimeter is a major victory in hardware design. It gives engineers more internal space to work with and far greater flexibility when laying out dense logic boards. That extra physical margin is strictly required when designing flagship mobile phones, high-performance AI wearables, and extended reality headsets. By achieving an ultra-compact footprint without sacrificing processing speed or battery efficiency, the new chip resolves the final piece of the mobile AI trilemma. Because of these hardware advancements, mobile storage chips are taking on a different functional role within the device. Storage has become the active infrastructure that drives AI computation, meaning its speed now directly determines how well a local large language model performs. Samsung is scaling these chips up to 1 terabyte capacities, with mass production of UFS 5.0 beginning in the fourth quarter. By ramping up supply now, the company is preparing to meet the demand of a market that is rapidly pivoting toward next-generation devices built around local data processing. We are moving past the need to rely on remote cloud servers. The raw capability to run high-level generative AI is now locked securely into the hardware sitting in our pockets.